You're intelligent young people. What we are going to do right now requires you to know something that you learned in probably 8th grade and then apply it to something we are doing right now. You can all read that sentence. I do not read it to you. This is not story time. Read it, and then we'll talk about what it means. Has everybody read it? Excellent. To add and subtract variables, what is 5x plus 3x? 8x. Why? Gideon.
Because you have 5 x's, and then you add them to 3 x's, which makes 8 x.
So x is just a letter, right? Yeah. So you all remember algebra tiles? Uh-oh. I used them this year. There's 5 of them, right?
Yes.
Plus 3 more of them, right? Yes. For a total of 8 x's. Yeah? Excellent. Okay. What is 5y minus 8y? Negative 3y. Okay, you wise asses. What is 5x plus 8y? 5x plus 8y. All right, okay. You think you're pretty hot poo. 5x minus 3y plus 8x plus 9y. 13x plus 6y. All right. Can everybody do that? Then you can do what we're going to do today, and I could not have to teach. But am I going to not teach? Of course not. It's my job. That's kind of like saying, don't be Matt. I can't be. I have to be Matt, because that's who I am.
What if you don't know?
Anyways. Okay. So why were you all able to do this? What is it about this situation that made you able to get from the question highlighted in blue to the answer highlighted in yellow? Ethan, hit me. Pairing like terms. Now, each of these terms has similar components, yes? There's this, which is what? The coefficient. And then there's this, which in this case is a variable. What math is happening right there? Multiplication. So this construction in math is a coefficient times what we call an argument. Because it might not be a variable, right? We could have 5 and 3. 5 is still a coefficient, but that would give us 15. Everybody understand? I could have 5 pi. That's 5 times pi. Everybody good? This is the argument. Yeah? We can add these things if our arguments are the same. We can add. Now, I only said add. I did not say subtract. Why? Is it different? Well, I'm asking you, Roy. Is it different? No, of course not. Subtraction doesn't exist. It is the addition of negative numbers. But math guys are so lazy, they don't want to write 5x plus negative 3x. So they invented 5 minus 3. That's the only reason it's there. It doesn't really exist. Everybody cool? All right. Now, knowing what you know, and you have already seen this, what is this? Is that not a coefficient and an argument? Okay. So could I add that to another coefficient 6 and the same argument? And what would I get? 11 root 2. Just like here, we got 13 x's. Here we're getting 11 root 2's. Does everybody understand? Okay. Could I do this? 5 root 3 plus 6 root 2. No. Could I do this? 5 cube root 3 plus 5 root 3.
Yes. No. We wouldn't be able to use
because they both have the same
add the
argument.
coefficients together. You would not be able to do that. Because that one's a root, and that one's
They're the same argument. Same number under the root, so that's why you can do it. It's like, yeah. It's like, I think you can do 5 cubed x and then plus 5 x.
So Lolith's argument is, since the radicands are the same, I should be able to add them together. So what do you feel the answer would be? 5 to the power of 4 root 3.
No, look at what you did with the top.
I don't think it's.
No. No. Okay, let me change it slightly because I think the way I've written it is confusing people. Can I add those? No, because this was the index, right? Now, what Lolith was saying was he thought I had 5 to the third up here. That, of course, you could add because that's 130 root 3. But it was really an index. Okay? So this is also a no-go. Everybody good? No new concept, right? Okay, so let's look at this very first one. Can I do that? Why? Same argument. They have the same radicand, so I can do that. What is not written there that I have to remember should be written there? That one. So what is this answer? 3 root 3. Now, Ethan, you had your hand up.
No, I was just going to say that you could.
Oh, okay. Can I do B? Of course I can. What is the answer? 8 root 6. Everyone is on fire today. Can I do C? Kinda. I can do a bit of it because what do I have here? I have 5 minus 3 minus 4 root 7s, and then I got me a root 2. What's 5 minus 3 minus 4? Negative 2 root 7 plus root 2. Now, sometimes math people don't like a negative there, so they do this. Root 2 minus 2 root 7. Is that the same value? Yes. All right? So you guys do D. What is it?
Oh, wait, are we asking one? You're asking the answer.
Well, it says try, so yeah.
Negative root 6 plus in bracket negative 2 root 3.
We wouldn't write it that way because we're math people, so negative root 6 minus 2 root 3. Everybody good? Now, you will notice, as always, the basic principle of everything we do is very, very easy, right? If they look the same, add them up. That's essentially what we've talked about today, yes? If you stopped listening there, you would not be able to do that, would you? But fortunately, before I got you to do that, I got you to read that sentence. What does that sentence say? Simplify first. Because when should we simplify in math class? Every single chance you get. Because the verb simplify means make it simpler. Why wouldn't you do that every chance you got? So some of you, even on your quiz and test on this, your first instinct is to be, oh, I'm done, can't do it. And then hopefully you will say, oh, no, I got it. And then you will simplify. This is, of course, what? Well, I would use 16 and 2. Why would I use 16 and 2? Because 16 has a square root. Now let's pretend you didn't do like I said and memorize your perfect squares, and you went 8 and 4. Well, then you would go 2 and 4, right? And then you would see there's a group of 2, right? And you would bring them out and you would leave the 2 under there. Agreed? And then, of course, you would go to 8 and you would say that is 4 and 2. And you would stop there because 4 has a square root. What is it? So you would bring that 2 out and you would leave that 2 as a radicand. And now you have 4 root 2's in black and 2 root 2's in red for a total of 6 root 2's. And if we mix black and red, we are going to end up with brown. And that would be our final answer. Because you cannot simplify root 2 anymore. Easy peasy lemon squeezy, yes?
Yeah.
All right. So what's going to happen in B?
Same thing.
Amazingly, math is going to follow a pattern. What's that going to be? 4 and 7. What's going to happen there? You can bring out the root of 4. You could factor it more, or you can stop, because you know the square root of 4 is what? So that's 2 root 7. What's that one going to be? 9 times 7. What's coming out? Minus 3 root 7. What's that one going to be? Well, that one's a pretty big number. So you might be in trouble. I, of course, would say that is 16 times 7. But most of you probably aren't comfortable with your 16 times table. So when we get to a bigger number, we just break it down the way we can. That's 56 and 2. That's 7 and 8. And then that is 4 and 2. And you would see there's a group of 2, so I bring out a 2. There's another group of 2, so I bring out a 2. Gone, gone, gone. And I'm left with 4 root 7, which is exactly what I would have gotten if I did 16 times 7. And now what do I have? Hey, Mr. DeVries.
Hey.
Mr. DeVries, I am in... I don't know if it's going to happen because Leo insists it's a power supply.
Yeah, well, feel free. Buy it.
Okay.
I'll sign it.
Okay.
As long as you can install it, we're good to
Oh, I can install it. It's one screw, plug and play. Oh, wait, unplug, plug, play.
You don't have the same projector as me.
No, I do not. So, what do we see here, ladies and gentlemen? I see the same argument, right? So what do I do with the exponents? Coefficients. 2 minus 3 plus 4 root 7, which is 3 root 7. No new concept. If you can add like terms, and you know you've heard your teacher say that a million times, you can deal with radicals. We have no problems.
So we have one on the next one. I forgot.
So everybody, oh, that looks awfully familiar, doesn't it? Except what's different from the question you just did? There's coefficients. So when you bring out this 2, what's going to happen?
Times 5.
So what do I get? 10 root 7s.
Minus 9 root 7.
minus 9 root 7s, and
8. 7.
8 root 7s, which is 10 minus 9 plus 8
9.
root 7, which is 9 root 7. Are we all good? Now, if it works once, does it always work?
Yes.
Well, let's have a look at this situation. Because when we look at that, most of you immediately, first reaction, it doesn't work.
We're done for.
What?
Impossible.
Why would it not?
Well, because 4C isn't the same as 9C, Roy. Of course. When it doesn't work, we simplify. Yes?
Why don't we find the least common multiple?
You don't need to, though.
Oh, okay, never mind.
Because
That's why.
what's the square root of 4?
2.
2 root C. What is the square root of 9?
3.
But there's already a 4 there.
Times it.
So it's minus 12 root C.
Wow.
What is it?
So cool.
It's negative 10.
Any questions? I want it to stay this easy.
Go back up. Stay there. We can always skip to quiz 2. We can always skip to quiz 2.
What happened
And then
to
avoid
Now,
Like how this exists in trigonometry. Just showing an example.
don't cheat. You're not going to do that with trig. You're going to do it with radicals.
Yeah, I know. But
Okay.
I'm saying that's like an example. Like
Yes.
we're showing how it exists in there.
Are we all good?
Here, yes.
Easy peasy lemon squeezy, yes?
Yeah.
When we talk about the triangle.
But just chill. Is everybody okay? To there. Now, your next thing is the giant triangle, yes? Which I don't know why it is not on my screen.
What is that? What was the word?
So I will need to borrow someone's book so I can sketch it quickly. Ah! Like a vampire.
All I remember is Sokotoa.
But you don't know.
What? I can't use Sokotoa.
Well, that's trigonometry.
Thank you, Roy. All right. Now,
Basically shows how this is found in another example. We like examples.
I remember now why this is not on my page.
How do I do that again?
Because,
Sokotoa.
well, it's kind of Sokotoa.
What is it?
It's kind of Sokotoa. Because I used to do trig before I did this unit, but then I moved trig to the end. So, since this is a pre-dip class, you've all done some trig, right?
Not enough to remember.
So, what I'm going to do is I'm going to give you one piece of knowledge here that isn't actually trig, okay? I'm going to show you this. If this is 30, this is 90, and this must be 60, yes?
Yeah.
All right. Every 30, 60, 90 triangle shares the same, the same proportions, okay? This is 1 across from 30, okay? This is 2 across from 90. This is root 3 across from 60. Every single 30, 60, 90 triangle shares those proportions. All right, everybody cool? So just wait. If I drew this 30, 60, 90 triangle, and I told you this was 15, how long would this be? 30. And how long would this be? 15 times the root of 3. Does everybody understand? Everybody follows me? Somebody who does follow me, because a bunch of people said no and shook their heads. Why, if this is what I told you, why is that true? Jada. Why? Because this was 15 times bigger, and I have to keep my proportions. Yeah? So this was root 3. It needs to be 15 times bigger. 15 times root 3. Is everybody good? What? But I just explained that. What does this mean? 15 times root 3. So if this is 15 times bigger, and this is 15 times bigger, that root 3 has to be 15 times bigger. And it's done. Now, let's apply that knowledge over here. This is 30, right? So this should be what? Yes, I know, but what should it be? It should be 1, but it's 30 times bigger than 1, isn't it? So what does that make this? 30 root what? 3. This is 40. So what's this? 40 root 3. So how big is this? 70 root 3. And then it's done.
Yes.
Now, like I said, normally I've done trig already by now. That's why it's still in your book. I forgot to delete it out of your book. Okay. Everybody good?
Yeah.
Gideon first, what?
Never mind. We're doing something else right after. I was going to ask you to go over, to refresh us on the rules of trig.
But we're doing a whole unit on trig right here.
Okay.
There's no need to do that. Yes. Trig is my favorite kind of math, so I like to save it for the end so I can leave feeling great. I loves me some trig, Roy. Loves me some trig.
Do you then also love review at the very end?
No, I hate review.
Okay. We should have done review first.
I despise reviewing because everybody's like, Mr. Myers, I need some review. And I say, pick up your book. And they say, okay. And I say, there's your review. What do you mean? You've done every question in there? Yeah. Take it back, flip through, find 87,000 blank pages. Oh, no. There's your review. All right. Now, you are intelligent young people. Your page 45 should say that. Right? Now, what?
Yeah, you're so blank here. Why was that?
Oh, that's super lame. This font is called Blush Bear.
Ours is in sans mono.
Super lame. All right. Now, ladies and gentlemen, you know that I usually take textbook pages for you to practice from, yes? But this is so easy. I'm just going to write a few up here, then you're going to write them down and do them, because we're only going to spend one day on this. Today. Because all you're doing is adding like terms, which you learned to do years and years ago. Right? Yeah. So I'm going to turn up the screen. You talk amongst yourselves for a moment. I'll write a bunch of questions, and then we'll carry on. Okay? Okay.
I love that.
Yes, you may, Rachel. Yes, you may. Okay. Here we go. Just like Daniel Cook. He was a stupid kid that had a TV show that was on kids' channels years ago. And he would go places and they would film it. And every time he said, "This is Daniel Cook going to the aquarium," and he would go, "Here we go!"
Oh my gosh, I remember that. Oh,
and now it's not Daniel Cook because they decided that Canada is a more multicultural society, and they got rid of Daniel Cook because he was a short white kid. And then they brought in, what was her name? No, it was a young Asian girl. Emily Young. Emily Young, yeah, this is Emily Young going to the aquarium. And then Emily Young went, "Here we go!" See, you guys are too young for Daniel Cook, but you all know Emily Young.
okay, so what's it called? Mars, do you remember the show Are We There Yet? When they were like, "We're selling Canada today," or "We're celebrating Canada today in Canada," and then they play Rusted Roots. What's it called? Send Me On My Way.
My baby cousin just learned it, and when he started singing it to me, I'm like,
You've got fire.
yeah, and it was like, it just pulled it up like the deepest part of my brain.
Okay, let's see what you got.
So like, for example, we do like one question, we do it for one.
All of you should look at the first one and go, "Pfft, not even worth sweating about." The second one, you'd be like, "Damn, I'm going to have to think about that." The third one, you're going to lose bladder control. But you're going to be fine.
Yo, why did you make it red?
I made it red to scare you. Danger, Will Robinson, danger!
You knew damn well that was good.
Of course, that is from Lost in Space, the original Lost in Space, not the new one where the robot is a badass mofo. If you haven't watched the new Lost in Space, you're missing out. It's a great show. It's on Netflix. Of course it's better than the old one. But the old one was, funny. You guys just wait till I show you the next page I'm going to get you to do. Dun, dun, dun.
We already did multiple.
Because why wouldn't you start with adding and subtracting? There you go. That says 9 cube root 48. Exactamundo. Did you go straight to the red one? Oh, okay. Yes. But you gotta have your mouth like that or it doesn't work. Oh. I'm gonna pause that there. Really hurts my thumb. All right, now, let's go. The other one, not the other one, the other one. The other one? No, the other one. You mean this one? No, the other one. The other one? Yeah, that one. Are we ready? Are we ready to put on our big person pants?
I don't have any of those.
Here we go. Crack your knuckles, stretch your spines. Let's do this thing. What is the problem term? What is the problem term here? Which one of these bothers you right now?
All of them.
This should bother you the most. So, 9 cube root 48 over 2 plus. All of you need to be aware that this construction, this is one part of it, right? This is the second part of it, right? What math is happening right there?
Multiplication.
So this is really 3 over 4 times the cubed root of 162 over 1. That stays with the 3. So it becomes plus 3 cubed root 162 over 4 minus 3 cubed root 750 over 5. Now, that's the, remember, there's more than one way to do this. Okay? I am going to do the most possible steps of math I can do because I also want to reinforce how we add and subtract fractions because a great many of you are a little bit poopy at adding fractions. What do you need to add fractions? What is the common denominator? It is 20. So what did this have to multiply to get to 20? So what does this have to multiply? So what do I get? 90 cube root 48. What did this have to do? So what does this have to do? So what do I get? What did this have to do? So what does this have to do? Minus 12 cubed root 750. Everyone should have been able to get to there easily, and then from there, it's nothing new. What should you do every time you see a radicand? Simplify it. This guy, and I'm going to make it easy on myself, this guy is 8 times 6. Why did I choose 8? Because it has a cubed root. What is it? So what comes out here? So what happens there? 180 cube root 6 plus 162 is 27 times 6. Why did I choose 27? Because it has a cube root. 27 is 3. So what do I get? 45 cube root 6. And lastly, 750 is you could do 75 times 10 and then break it down again. I wouldn't. I would do 125 times 6. Why? Because I've already seen 2 root 6's come up, haven't I? So what is a logical thing? It would be a logical thing to try 6, wouldn't it? Which is 6 goes into 7 once, goes into 15 twice, goes into 30 5 times, so it's going to be 125 and 6. What's the cube root of 125? So what comes out? What is that? Now what are you going to do with all of that? Add it up. 180 plus 45 is 225 minus 60 is 165 cube root 6 over what? 20. Would Mrs. Bad Crumble ever let you leave that fraction?
No.
Heck no. So what are we going to do with that fraction?
Simplify.
To get 33 over 4 cube root 6. Is that okay? Is 33 cube root 6 over 4 okay? Both of them are the same thing. Now again, did any new concept get shown to you today? No. You just applied this concept that you've already known to simplifying radicals, right? Everybody good?
Shouldn't be getting used to questions like that pretty soon.
Very soon. Now, I am going to bring up a page on the screen right now because you notice what's the next thing? No. In your books, what's the next thing? Am I going to start a new lesson with only 19 minutes left in class? What kind of an idiot do you think I am?
We don't think you're an idiot.
So, here's what you're going to do. Here's what you're going to do. You're going to do this. You can do it on your own piece of paper. Start with those 2 questions. If you would like paper, I have some as well. It's not in your books. That's why it's on the screen. That's why I said you need your own paper. I will sauce you some paper, Roy, because I understand your hip kid slang. When I give it to you, I might even dab. I'm joking. I'm blind. Consider it sauced.
May I have?
Ladies and gentlemen, if you are going to take 20 minutes to do this question, you're in big trouble. So I would get working, or you. Because as you can see, that's only A and B. You're a fool if you don't think there's a C and D. So if you're lining up to go to the bathroom, you're going to use your once out of 2 trips to the bathroom on the first day, you're welcome to do so. You get 2 trips out of the room a week. If you're going to use them on the first day, you're welcome to. Yes, actually. Wait till you get MJ. You don't get any trips out of the room. So we should be very thankful that your gracious math teacher offers you 2.
I sure do love French class.
J'aime la classe française et la langue belle.
Je déteste le français.
No, beautiful language. It's a
What
did he say? Wait.
long beauty.
Yeah, the only people who like
Really tall supermodels. Their beauty is long. I love that your first name is a French name too. That makes it even better. Okay, well, because 10 plus 18 plus 20 is 48. Is everybody good? All right. This is a mixed radical, yes? If there's a single 48 out here, how many 48s are under there? 2. So this would be the root of 7 times 48 squared, which is a giant number. You will use your calculator to find it. And what is it? Pardon? 16,120. Yeah? 28. Thank you. Yeah? Everybody can get to there, yes? Now, maybe you don't have the right numbers because you forgot something somewhere, but everybody's cool, yeah? All right, now I'm going to show you something that you have never seen before, but you have the ability to deal with it if you think. What would be which of these two numbers, and these are your two choices, 48 root 7 or the root of 16,128. Those are the perimeter, yes? How would you guess you would find the half perimeter? Okay, so which one of those would be easier to divide? Absolutely the 48. Why, Roy?
Because you can't divide the numbers.
Because that is a root. Now, how did I teach you how to deal with the math of this? I said it was the same as variables, yes? So if I had 15x divided by 3, what's the answer? So what is the half perimeter? 24 root 7. Excellent. You've never seen anything. You haven't seen division with this yet you were able to figure it out. Now let's move forward even further. Using this formula. You have never seen that formula before, have you? But I will tell you that S equals the semi-perimeter. What does semi mean? Half. So do we know what S is? Yes. A equals the side 1. B equals side 2. And C equals side 3. Find me the area by filling in this formula with the knowledge that you have. And that will take you about the 10 minutes left in class. Go. I'd finish off this as far as you could go. Square root of S, 24 root 7. A, S minus A, 24 root 7 minus A, we simplified right here to 10 root 7. So that is 10 root 7. S minus B, 24 root 7 minus We simplified that one to 18 root 7. And then the last one was 24 root 7 minus 20 root 7. 20 root 7. And then 24 root 7 times 14 root 7 times 6 root 7 times 4 root 7. Now, you could go times, but I haven't taught you that. Or you could remember the square root of 18 is the same as the square root of 3 times 3 times 2. And you take out that, right? Well, look at this. I see 1, 2, 3, 4 root 7s. So I can bring out root 7 squared, and they are gone. Square root of 4, well, that's 2. It's gone. Square root of 24, well, that's 4 times 6. So I can take out another square root of 4. There's 2 6s. I can take out a 6, and that is 2 times 7. No pairs there, so I've got 24 times root 7 squared, root 14. Root 7 squared is 24 times the root of 49, which is 24 times 7, root 14, which is 168 root 14. Dun, dun, dun! There you go.